Okay, so we're going to kind of explore how the Pythagorean theorem and the distance formula are related. I have brought down the points from our previous example up here using a and b at -2, -1, and b at 1, 3. Just use the same points so we can see how this all works out. So the Pythagorean theorem, as we remember, is for a right triangle. And sides A, B, and C always being across from that right angle, what we call the hypotenuse. And the formula is a squared plus b squared equals c squared. Now, what if I turned my graph with a and b on it into a right triangle? I graphed that into a right triangle. So if I dropped a straight vertical line down from point B, and I created a horizontal line from A and created a right triangle, could I use that right triangle to find the length of AB using Pythag instead of the distance formula? I absolutely could. Or I could just realize that the distance formula and Pythagorean theorem are actually one and the same, just a little bit different. With Pythagorean theorem, we are taking the length of the sides, so from one entire length as A and one entire length as B, and then the hypotenuse is C. With the distance formula, we are, instead of being given the entire length of a side, we're given points to find that length of the side. Now, the place where my right angle is in this corner is at the point 1, -1, because it's the exact same x as I dropped down that vertical line from my B, and the exact same y value as I moved horizontally from A. If I want to find out the length of this line A, I would need to find the number of steps from point A to where my right angle is. And I'm going to name that point C. Capital C there. Big C. And so I could, as if it was on a number line, count the steps, or I can subtract the x values. So I'm going to start from C, our x value, minus the x value of A. So I'm going to call this x2 and x1, which you might remember from the distance formula. So if you remember the distance formula, we take that square root, x2 minus x1, and we square it, plus y2 minus y1, and we square it. So we're going to see if there's some correlation here. So I take that x2 minus that x1, which is 1 minus a -2, which turns into +2, which gives us 3. So I'm going to plug that into my distance formula. And then I'm going to do the same for side B. Except for, since this is a vertical line, I'm going to do the y values. So I'm going to do y2 minus y1, with my y2 belonging to point C and my y1 belonging to point B. So y2 is -1 minus 3, and that gives us a -4. But remember, side lengths are never negative in reality. The value right now says -4, but if I was just counting this in steps On a number line, it would just be 4. There was a length of 4 between the two. So I'm going to go ahead and plug this into my distance formula and square it. And we have 3 squared is 9, plus negative 4 squared gives us 16. Negative squared becomes positive, and that gives us root 25, which we know the square root of 25 is 5. Now, if I just gave you a triangle, and I asked you to find C, but I gave you a side length of A, and the steps from one side to the other was 4, and the steps from B to C was 3, or actually, these were the other way around. This side was 3, and this side was 4. And I just asked you to do Pythagorean theorem. You would take 3 squared plus 4 squared equals C squared. Now, I immediately see a similarity with what's going on here and what's going on here. They're slightly different, but still very similar. And the reason would be if I were to go ahead and square root both sides. So if I took the square root of both sides, that would cancel out the square root on my C, and I would be left with the square root of 3 squared plus 4 squared equals C. And now, does this and this look similar? Do we have the same information and the same result using the distance formula in Pythag? We do. We just have to remember that side lengths are never negative, and so that will eliminate this negative symbol here. But we can take the Pythagorean theorem or the distance formula and substitute them for each other based on the information that's provided for us. So to summarize, looking at our distance formula, this piece of information and this piece, that x2 minus x1 squared, is measuring the length of a side. And so is the y2 minus y1 squared. Not the square root, but there we go. That's a little more accurate length of side. So even though subtraction is happening in the distance formula, that subtraction is just finding the value of the side length of our triangle. If we are just given a triangle, we already know that side length. We're not having to subtract at all because we're not using coordinates. It's just given to us as a measurement. So there is this correlation and relationship to our, see, these are our lengths of sides as well. There we go. There is a correlation or relationship between Pythagorean theorem and the distance formula.